Good evening, everyone. Today I'm going to take you into a world that's both incredibly small and unbelievably strange. The world of quantum physics. Imagine zooming in closer and closer on your hand, past your skin cells, past the molecules, and down to atoms. Now, for many years, scientists believed that atoms were the smallest building blocks of reality. But later studies showed that atoms are made of even smaller particles. Electrons, protons, neutrons. Quantum physics is the branch of science which studies how these particles behave. Now, here's where things get strange. In our everyday world, if you throw a ball, it travels along a clear path. You can predict where it will land. Classical physics, described by scientists like Isaac Newton, works beautifully for these large everyday objects. But at the atomic scale, particles don't behave like tiny billiard balls. Instead, they behave more like particles and waves at the same time. This idea was first formalized by Erwin Schrödinger. For example, an electron doesn't orbit the nucleus in a neat circle. Instead, it exists as a probability cloud, a wave function described where it's likely to be found. Notice that word likely. One of the key principles of quantum physics is that you can never know exactly where a particle is with perfect precision. Werner Heisenberg showed that the more precisely we know about a particle's position, the less we can know about its momentum. But this isn't a limitation to our instruments. It's a fundamental property of nature. Even more fascinating is the idea of superposition, where a particle exists in multiple states at once until it's measured. You may have heard of Albert Einstein, who famously disliked some implications of quantum theory. He was especially concerned with a phenomenon called quantum entanglement, where two particles exist in multiple states until it's measured. Einstein called this spooky action at a distance, yet experiments continue to confirm that this spooky action is real. For a general audience, quantum physics tells us that the universe at its most fundamental level is governed by probability, uncertainty, and wave-like behavior. For scientists, it provides an extraordinarily precise mathematical framework, quantum mechanics, which predicts experimental results to astonishing accuracy. Technologies such as semiconductors, lasers, and MRI machines all rely directly on quantum principles. In short, when we look deeply enough into reality, particles blur into waves, and reality becomes far stranger and far more beautiful than we ever imagined. Thank you.
Thank you very much. That's an incredible amount of information to remember there. So 2 questions from our judges. Who wants to go first?
You go first this time, Josie.
Oh, okay. Where did you first find out about quantum physics? Do you remember?
I remember I was watching this video about atoms, and then I just decided, how did they actually behave? And then I just searched up something about behavior of small particles, and I found out that actually it's not the same as normal objects. It's completely different.
It's probably going down this rabbit hole.
Yeah.
Thank you.
So then, I'll ask you a similar question to what I asked the first contestant. Like, in your research, did you rely on background knowledge that you already had, or did you have to go and find some specific sources to write this talk?
So I used some research that I found on the internet, but then I just kind of continued on to understand it without needing much more research. I just continued.
I envy you. I don't understand it even with research.
Very tricky topic.
Yes.
Thank you very much. Very impressive. Thank you. Thank you.